Welcome to Z. Today, we're embarking on an extraordinary journey to explore the enigmatic world of Pluto, a celestial body that has captivated our imaginations and sparked intense debates for generations. Once celebrated as the ninth planet of our solar system, Pluto now holds the title of a dwarf planet. But what does that truly mean for our understanding of the cosmos? Join me as we delve into its unique characteristics, its intriguing journey through the solar system, and its significance in broadening our horizons about planetary science. Let's start with the basics. What is Pluto? Situated in the Kuiper Belt, a vast region filled with icy bodies and remnants from the early solar system, Pluto represents the diversity of our cosmic neighborhood. Discovered in 1930 by astronomer Clyde Tombaugh, Pluto was initially celebrated as the ninth planet, igniting a wave of enthusiasm and curiosity. For decades, Pluto was a source of pride as the most distant known planet from the Sun. However, as astronomers explored the outer solar system, they found numerous other icy bodies that shared similar characteristics with Pluto. This led to a re-evaluation of its planetary status. In 2006, the International Astronomical Union redefined the criteria for what constitutes a planet, leading to Pluto's reclassification as a dwarf planet. But why does this reclassification matter? It challenges our long-held beliefs about what defines a planet and encourages us to rethink our perceptions of celestial bodies. Now, let's take a closer look at what makes Pluto so unique. With a diameter of about 1,477 miles, Pluto is smaller than our Moon. Its surface is a breathtaking tapestry of nitrogen ice, methane, and carbon monoxide, giving it a striking reddish-brown color that changes with the seasons. The presence of these ices indicates that Pluto experiences significant seasonal changes, creating dynamic weather patterns despite its great distance from the Sun. One of its most notable features is Sputnik Planitia, a vast, heart-shaped glacier that spans over 1,000 kilometers across. This glacier is primarily composed of nitrogen ice and showcases large polygonal patterns, suggesting the presence of convection currents beneath its surface. The discovery of such features hints at geological processes that suggest Pluto is far more dynamic than previously believed. In addition to its surface, Pluto's atmosphere adds another layer of intrigue. It has a thin atmosphere composed mainly of nitrogen, with traces of methane and carbon monoxide. This atmosphere expands when Pluto approaches the Sun during its orbit and partially freezes when it moves farther away. This seasonal variation in atmospheric pressure is a fascinating aspect of Pluto's climate, providing clues about how similar atmospheres might behave on distant exoplanets. Pluto is not alone in its celestial dance. It has 5 known moons, with Charon being the largest. Charon is so substantial, nearly half the size of Pluto, that the two bodies actually orbit a common center of mass located outside of Pluto itself. This unique relationship makes Pluto and Charon a captivating double system. The gravitational interplay between them raises questions about their formation and evolution, suggesting they may have originated from a significant collision in the Kuiper Belt. Now, let's explore Pluto's remarkable journey through the solar system. Unlike the relatively circular orbits of the inner planets, Pluto's orbit is highly elliptical, taking approximately 248 Earth years to complete one full revolution around the Sun. To put that into perspective, a single year on Pluto is nearly 250 times longer than a year on Earth. Pluto's orbit is also tilted at an angle of about 17 degrees to the plane of the solar system. This unique tilt means that at certain points in its orbit, Pluto actually crosses the orbit of Neptune. For a brief period, About 20 years out of its 248-year orbit, Pluto is closer to the Sun than Neptune. This intriguing aspect of Pluto's orbit challenges our conventional understanding of celestial mechanics and highlights the complexity of our solar system. During its time in the inner part of its orbit, Pluto experiences different seasons that significantly affect its atmosphere and surface conditions. This complex interplay between its elliptical orbit and axial tilt results in extreme variations in temperature and atmospheric pressure, offering a dynamic environment for study. A monumental moment in our exploration of Pluto came with NASA's New Horizons mission. Launched in 2006, this spacecraft traveled over 3 billion miles to reach Pluto, making its closest approach in July 2015. The mission was not just a flyby. It was a landmark event in space exploration that marked the first close-up study of Pluto. The data and images returned were groundbreaking, revealing a world of stunning geological features, including towering mountains made of water ice, vast plains, and a thin, layered atmosphere. The New Horizons team received images that showed Pluto's surface to be more diverse than scientists had ever imagined, featuring bright and dark regions that indicated varying compositions and possibly even ongoing geological activity. One of the most exciting discoveries was evidence of possible cryovolcanism, where icy volcanoes might erupt with slushy mixtures of water and ammonia. This discovery opened up new questions about the internal heat sources that could sustain such activity in a distant, icy world. The presence of these geological features suggests that Pluto is not merely a cold, inert object but a dynamic world with a complex history. The mission also provided valuable data on Pluto's moons, particularly Charon, revealing a surprisingly complex geological history and the presence of canyons and other features that suggest tectonic activity. The images and data sent back by New Horizons have fundamentally changed our understanding of Pluto and its place in the solar system. Pluto's reclassification has sparked significant discussions within the scientific community about what it means to be a planet. As a dwarf planet, Pluto has encouraged researchers to explore other similar bodies in the Kuiper Belt, broadening our understanding of planetary formation and evolution. The Kuiper Belt itself is a treasure trove of information, filled with objects that can tell us about the early solar system. It is estimated that there are hundreds of thousands of icy bodies in this region, many of which have yet to be discovered. The diversity of these distant objects challenges the traditional view of our solar system and highlights how much we still have to learn. Each discovery adds another piece to the puzzle, enriching our understanding of the processes that shaped our cosmic neighborhood. Additionally, Pluto's unique characteristics, such as its atmosphere and surface features, provide crucial clues about the conditions that can exist beyond the main planets. The study of Pluto's atmospheric dynamics, for instance, informs our understanding of how similar processes might occur on exoplanets orbiting distant stars. The lessons learned from Pluto can help us unravel the mysteries of worlds beyond our own. Moreover, Pluto's journey has also highlighted the importance of revising scientific definitions and classifications. It has encouraged open dialogue within the scientific community and among the public, prompting us to rethink our notions of what constitutes a planet and why it matters. This evolving discourse is a testament to the nature of scientific inquiry, a continuous quest for knowledge. Beyond its scientific significance, Pluto has made a profound cultural impact. It has inspired literature, movies, and even a devoted fan base advocating for its planetary status. The emotional connection many people have with Pluto highlights how scientific classification can influence our perceptions of identity and belonging. For many, Pluto represents the underdog, the small, distant body that continues to defy our expectations. Its journey from planet to dwarf planet illustrates how our understanding of the universe evolves over time, reflecting the dynamic nature of science itself. This story resonates with many, reminding us that the quest for knowledge is a never-ending journey filled with twists and turns. Pluto's reclassification also sparked a broader conversation about the nature of scientific authority and how definitions can change with new discoveries. The phrase, "once a planet, always a planet," has become a rallying cry for those who wish to see Pluto restored to its former status. This cultural phenomenon emphasizes the deep emotional ties people have to the cosmos and their desire for connection with the universe. Pluto may be classified as a dwarf planet, but its journey through the solar system is anything but small. From its intriguing surface features and unique orbit to its role in redefining our understanding of planets, Pluto continues to captivate our imaginations. As we uncover more about this icy world, we deepen our appreciation for the complexities of the cosmos and the endless wonders it holds. The story of Pluto is one of exploration, discovery, and a reminder that there is so much more to learn. Each new piece of information not only enhances our knowledge, but also fuels our curiosity and passion for the universe. Thank you for joining me on this exploration of Pluto's journey. Until next time, keep looking up, embracing the mysteries of the universe, and dreaming big.